Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on digital modulation. Okay, for this video, I'm going to concentrate on the different types of digital modulation. In short, we have actually three main types of digital modulation, which is ASK, FSK, and also PSK. ASK stands for amplitude shift keying. Okay, so like the name implies, it actually changed the amplitude according, okay, to the modulating signal. We have this FSK, okay, which stands for frequency shift keying. Okay, so again for FSK, they actually change the carrier frequency to correspond with the intelligent signal. And last but not least, PSK actually stands for phase shift keying. For this case here, they actually alter the phase according to the modulating signal. So basically, this will be the objective of this video. We are going to take a close look on the different types of digital modulation and how we can actually plot them in a time diagram. This will be the part 2 series discussion on digital modulation. So guys, if you're keen to know more about digital modulation, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on modulation. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me your question through the comment. Before I continue, I'd like to urge you guys to help this channel by pressing the like button. Okay, when more you guys actually help to press this like button, okay, this video will have a better chances to reach out to a larger audience. So guys, give me a few seconds. Help me press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Before we go into the discussion, okay, on the digital modulation, let's do a quick recall. What is actually modulation? Okay, so modulation, in fact, is a very fundamental process in a communication system. In modulation, okay, we have this low frequency, okay, which is typically the signal, okay, that we actually want to send to the recipient. This low frequency or this original signal, they actually blend with a higher frequency carrier, okay, so as to enable the efficient signal transmission, okay, which is called modulation. So in short, modulation consists of low frequency, which is your original signal, mixed with high frequency, which is the carrier, to form the modulated signal, which we are going to take a close look here. For this video, I'm concentrate on the digital modulation. So in short, we have ASK, FSK, and also PSK. During modulation, okay, one of the three parameters of the carrier wave, either the amplitude, either the frequency, or either the phase, will be altered according, okay, to the amplitude of the message, the signal at a given transit in time. Okay, so basically this technique is critical for extending the range of communication, hence improve the signal to noise ratio and reduce the size of the antenna. So this you can actually look on the first discussion on the modulation, which explain the motivation why we need to have modulation. So in short, there are actually primarily two types of modulation. One is the analog modulation. So if you're keen to understand more on the analog modulation, okay, which is the amplitude modulation, frequency modulation, and the phase modulation. This video, like I emphasize, I will mainly cover the digital modulation. Okay, so basically, as I mentioned early on, the modulation actually fall onto the analog modulation and also the digital modulation. Okay, but as I so-called mentioned just now, the three very common one is the ASK, FSK, and also PSK. But this APSK, okay, which is the combination of amplitude and phase, or this QAM, they are actually quite similar. Okay, so I will again take another opportunity to explain this form of digital modulation. But this video, okay, again, I like to just concentrate on the ASK, FSK, and also the PSK. Okay, so let's quickly understand the key difference between this analog and digital modulation here. Okay, so in analog modulation, okay, both the carrier and the message, they are all analog wave. Okay, so this is actually for digital modulation, but imagine this is an analog modulation, which means that this, which is the modulating signal, is actually analog rather than digital. So the modulating signal I actually has an analog wave, while the carrier is also analog signal. So with this, we actually call this analog modulation. Okay, so if you still recall, under this analog modulation, we have amplitude modulation, okay, which is the amplitude, okay, of the modulating signal actually will alter the carrier signal according so as to appear as a modulated signal on over this side here. So this is for the analog modulation. As for digital modulation, it's a slight different. Okay, so basically from here you can see that in a digital modulation, the carrier signal will be still in an analog waveform, while the message basically will be in a digital format. So from here you can see that this is actually a digital signal. Okay, so what is analog and digital? Digital mainly consists of 0 and 1. So this is 0, this is 1. So basically we call this as a digital signal, okay, which is discrete. Okay, so this is the key difference between analog modulation and digital modulation is basically based on the modulating signal. Whether is it analog, then we call this as analog modulation. If this is digital, then we call this as a digital modulation. There are mainly three types of analog modulation, which I have explained earlier on, which is the amplitude modulation, frequency modulation, and phase modulation. Okay, so in this method, okay, either the amplitude, either the frequency, or the phase of the carrier wave change according, okay, to the amplitude of the message signal. So in contrast, okay, the digital modulation actually use a process which is called shift keying, as you can see from here, or the shift keying, okay, amplitude, frequency, and phase shift keying. What is actually shift keying? Okay, so shift keying means that the amplitude, frequency, or phase of the carrier wave is shift between two or more discrete values, okay, rather than very continuously as in analog modulation. Binary data actually require two discrete level of amplitude, which is 1 or 0, okay, or the frequency or the phase for modulation, okay, which is referred to as binary shift keying. Okay, so this video, I will mainly just concentrate on this binary shift keying. Okay, on my next few sequence of discussion, then I will concentrate on Mary shift keying. But like I mentioned here, this video, I mainly will just concentrate on this binary shift keying. And I will have some discussion on Mary shift keying, but I will leave the majority of this Mary shift keying on my next few video to discuss. So in short, there are actually primarily three types of digital modulation technique, which is the ASK, FSK, and PSK. For the amplitude shift keying, frequency shift keying, and also the phase shift keying. Okay, so this is how the modulated signal can be represented by this equation here. So when we actually change the amplitude, okay, so basically when we actually change the amplitude, okay, so this is what we call the amplitude shift keying. So when we actually change the frequency, okay, so this is what we call the frequency shift keying. When we actually change the phase, this is what we call the phase shift keying. Okay, so before I continue, okay, so if you had learned something from this video, okay, sincerely urge you to help this channel by like this video. Again, like to re-emphasize this, if this video is helpful, please help me to subscribe to this channel so that the audience of this learning community can be further enhanced. So basically, in short, based on whether you change the amplitude, you change the frequency, you change the phase, you have the various different form of shift keying. Okay, so let's take a closer look how we actually can draw the time diagram for this amplitude, frequency, and phase shift keying. Okay, so let's start off at the amplitude shift keying first. Okay, so basically, let's just do the two level first, which means that either is it a 0 or 1. Okay, if you keep this in mind here, okay, in order to have a digital modulation, the digital signal or the modulating signal must be in a digital format, while the carrier can be an analog format. So basically, after at the output here, this is what we call the amplitude shift keying. Okay, how they actually change. as I mentioned earlier on, the digital signal consists of either 1 and 0. And based on 1 and 0, I will actually modify the amplitude. For example, if the message is 0, I can have nothing to show. When the message is 1, which means that I have actually something on the amplitude to show that it is actually the signal 1. So basically, this amplitude shift keying is sometimes known as the on-off key, because this is off, this is on. And based on whether the key is on or off, I will be able to determine the digital signal. Okay, so basically this is the easiest form of shift keying, which is the amplitude shift keying. Okay, so let me give you a clearer example how we actually can do this. For example, this is the message that I want to do a amplitude shift keying. Okay, I duplicate this so-called amplitude shift keying message here. And this is actually the outcome of this amplitude shift keying, the ASK. How can I actually obtain all these results? Okay, so as I mentioned here, these are all the message, the 1011, okay, the 0101. So this is the message. Okay, again, I like to re-emphasize this. Earlier on, I did mention that when the message is 0, I have nothing. When the message is 1, I actually will show you a waveform over here. Then basically, from whether you have waveform or without a waveform, you will be able to decode the message. So basically from here, if I have something, I know that this is message 1. And if I have nothing, I know that this is message 0. Again, something, so therefore I know that these are all message 1. Nothing, therefore I know that this is message 0. Something, again, I know that this is message 1. Nothing, message 0. And something, this is message 1. Can you see over here? Okay, I can easily represent the digital signal using amplitude shift keying. By controlling whether on or off, I will be able to represent this string of digital signal here. So basically, this is what known as amplitude shift keying. Okay, so which is 2 levels. Okay, so let's take a close look. Okay, what does all this mean here? So I have this simple diagram to do a simple conclusion. So in short over here, if you have something, then you just need to show some waveform over here so that I will be able to know this is 0, 1, 0. Okay, so but sorry, this is 0, 1, 1, 0, 0, 1. Okay, so basically this can be 0, 0, 1, 1, 1, 1, 0, 1, 10 here. I guess you know what I want to say. So basically, if the message is 1, you can see that I actually have some so-called waveform here. And again, from here, you can see that if the message is 1, I have some form of waveform here. And based on all this, I actually can be able to decode the input binary sequence. Okay, so basically, this is the amplitude shift keying, okay, for the 2 level. Okay, let me quickly discuss on the amplitude shift keying for the 4 level here. Okay, so in short over here, earlier on, I did mention that by the amplitude here. So basically, this is amplitude shift keying. Okay, so basically, if the message is 00, I show you nothing. If the message is 01, I show you a very little signal, okay, the amplitude, which is the smallest over here. And when the message is 10, I increase the amplitude slightly. And when the message is 11, I have the largest so-called amplitude. Again, from here, if you look at the amplitude, you will be able to determine what signal has been sent. So basically, in short, over here, you can see that, again, this is the same amount of data that I actually want to send. And based on the waveform over here, you can see that this waveform is actually this waveform, which means that a message 10 is actually sending over. This having the largest so-called amplitude, so therefore I know that this is message 11. And these two having the smaller message, okay, which means that the message is actually 01. Can you see over here again? The message can be easily so-called indicate the input value of the digital signal. From here, you can see that it will take a shorter time to send the signal. Early on the 2 level, you can actually see that I actually take a longer time to send the signal. Okay, because every time when I actually see this waveform, I can actually extract up just only 1 bit of data. While for this 4 level here, actually, every time when I see signal, I actually manage to extract up 2 bits of data, which means that my throughput actually increased by 2 times. So basically, this is the meaning of amplitude shifting. Again, from here, you can see that by properly control the amplitude, okay, so basically from here, you can see that instead of 1 bit, every time you can actually obtain 2 bits of data. Okay, as you can notice the key difference from the amplitude of the signal here. So basically, this is the conclusion on the amplitude shift keying. Okay, so basically from here you can see that either the 2 level or the 4 level of amplitude shift keying. Okay, so next, okay, I like to concentrate on the frequency shift keying. So what is actually frequency shift keying? So earlier on, I concentrate on amplitude, but over here you can see that I will concentrate on the frequency. Okay, so when the message is 0, okay, for example, for this case here, I will be able to indicate with a lower frequency. And when the message is 1, I will be able to indicate the message with a higher frequency. So again, okay, based on the digital signal of the modulating signal, whether is it 0, whether is it 1, I will indicate by the frequency. And again, from here, you can see that how I actually able to so-called represent this digital signal over here. Again, let me use all these as I illustrate earlier on. Okay, so basically these are the same so-called digital signal that I actually want to send over. So under this frequency shift keying, okay, so note this is actually 2 level, which means that either 0 or 1. Okay, again from here, this is the original message here. Again, with a higher frequency, okay, basically this is message 1. Lower frequency is 0. Higher frequency is message 1. Lower frequency is 0. Okay, higher 1. Lower frequency, which is 0. Again, this is higher frequency 1. So basically, you can see that, okay, basically this set of digital signal can be represented by frequency shift keying. Okay, so basically by looking at the frequency, whether is it high frequency, whether is it low frequency, I will be okay, to represent this digital signal by the frequency shift keying. Okay, so basically this is the frequency shift keying with 2 level. Okay, so again, okay, I have a very quick conclusion over here. So basically you can see that this is message 1. I actually has a higher frequency. I have this message 1. I have something that is higher frequency. This whole chunk here, okay, with message 1, you can actually see that I actually has a higher frequency. Same over here. So basically from here, you can see that I can actually represent the input binary sequence with the frequency shift keying. Okay, so basically this is with 2 level. Again, for frequency shift keying, I can actually do with 4 level. How can I actually do with 4 level? Okay, so basically again, frequency shift keying is mainly to control the frequency. Okay, so when the frequency is 00, this will have the lowest frequency. And when the message is 01, I will have a frequency that's higher than this, okay, with the message 00. So from here, you can see that this actually has a higher frequency as compared to this. And when the message is 10, again, I would like to increase the frequency of the signal. And this message 11 has the highest frequency. Okay, and basically, based on the same example, same message that can actually use to represent the digital signal, I can actually represent as seen over here. Okay, so basically based on the frequency, for example, this is 10. Okay, so this is actually 11. Okay, so basically from here you can see that this is 01. And again from here, I can easily represent the digital signal with frequency shift keying with 4 level. Again, you can see that once I have this 4 level, okay, my throughput will be double. Okay, because every time, every one slot, instead of 1 bit, I actually will be able to obtain 2 bits of data. Okay, so basically this is the attractiveness of shifting more levels. The more levels I can actually achieve, the more numbers of bits I can actually obtain, which further enhance my throughput. Okay, so basically this is frequency shift keying with 4 level. Okay, so next, okay, so basically most of the communication device now fall under this frequency, the phase shift keying. Okay, so again, let me go through the very easier one, okay, which is the 2 level, okay, 2 level of phase shift keying. Sometimes we call this binary phase shift keying. Okay, so basically this is what I have described earlier on. Okay, so basically for a digital modulation, the digital signal need to be the digital form, okay, in order to have this digital modulation. Okay, again from here you can see that for this binary, I can have this falling edge or rising edge. From here you can see that when the so-called the start time here, and if this thing start to fall, therefore I know that this is message 0. When the message start to rise, okay, basically I will know that this is message 1. Okay, so let me just re-explain this. From here, you can see that the first cut here on the time, you actually see the thing fall. So this is message 0. When on that particular time, you can see that it actually rise. So this is actually message 1. Okay, again, this is the same message. And basically, I cut all the so-called the time, the start time. And basically, you can see that whether is it rise or falling, I will be able to decode the message. From here, you can see that very obvious, this is rising. So therefore, it's a message 1. Can you see here, this is rising. So this is a message 1. Okay, over here, you can see that this is actually falling. So therefore, this is a message 0, as you can see from here. Okay, from over here, you can see that the message actually rise. So therefore, this is message 1. Same for this here, the message actually rise. So therefore, this is message 1. This message actually fall. So therefore, this is a message 0. This message actually rise. So therefore, this is a message 1. Same for all this. So basically, from here, you can see that based on the phase, okay, whether is it the 0 phase or 180-degree phase, or whether is it falling edge or rising edge, I will be able to represent the digital signal with phase shift keying. Okay, so basically this is actually to let you see how easy or how difficult it is. Okay, so again, I can do a quick conclusion, okay, based on this phase shift keying here, based on whether is it rising, as you can see from here. If it's 1, I will have a rising. So if it's 0, I have a falling. If this is 1, I actually has a rising. And if this is so-called this is 0, I actually will have a falling. Okay, so this is a rising, so therefore I will is 1, so I will have a rising. So basically, this is how I actually can represent the input binary sequence with this phase shift keying. Okay, again, the more challenging is always the more the level. Okay, so basically, this is the 4 level. Okay, so basically the 4 level, for example, 0, 0, I can be represented by the original signal. Okay, how can I actually get all this? Okay, maybe my next slides I will be more clear. Okay, so basically this is the original signal. I can actually represent by this phase shifting. Okay, so basically how to do this? Let me use my next slides to describe to you. Okay, for example, this is the signal here. So basically when I actually control my so-called my starting. Okay, so basically if my message is 0, 0, I will start my message over here. So therefore you will know that this is message 0, 0. This is a phase shift of 0. Okay, so once I actually has a message 0, 1 here, so I will represent over here. Okay, so basically once I actually represent here, you will know that the message is actually 0, 1. Okay, so basically this is how I actually can do. So basically this is next. Okay, if a message is over here, okay, so which means that the message is actually 1, 0. And last but not least, if my message actually appear over here, so therefore you know that my message is 1, 1. So basically in short, okay, if I start from here, okay, I know the message will be 0, 0. If I start from here, I know my message is 0, 1. And again, if I start from here, you know that my message is 1, 0. And when I actually start from this particular point, you know that my message is 1, 1. This is how I actually obtain all this signal here. So basically this is 1, 0. Okay, so as I mentioned earlier on, okay, I will have this signal over here. So if it's a 1, 1, okay, so basically as I mentioned earlier on, 1, 1 is actually I represent here. Okay, so basically from here you can see that this is the portion here. So therefore I know that this is a message 1, 1. Again, if this is message 0, 1, again based on my previous slides here, 0, 1 actually appeared right on top here. So basically from here, you can see that this is actually a 0, 1. And from here, I can actually represent the digital signal, okay, again, with the phase. By controlling the phase with 4 level, I actually can represent the digital signal, okay, with this phase shift key in. Okay, so basically, this is what I have. And I just want, again, with a quick conclusion here. Okay, so basically it's the same logic that I have explained earlier on. Okay, basically this is for phase shift keying for 4 level. Okay, so with this, I hope you have a better idea. Okay, what is amplitude shift keying, frequency shift keying, and also phase shift keying. By controlling the amplitude, okay, basically you will have amplitude shift keying. When we actually control the frequency, then we have this frequency shift keying. And then when we actually control the phase, then we have this phase shift keying. Currently, most of the so-called signaling is based on this phase shift keying, which I will emphasize a little bit more on this few next discussion here. Okay, so with this, I'd like to end my discussion. Okay, please help to like and subscribe. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.